So with equations and inequations, essentially what we're trying to do is make some pronumeral the subject of the formula, if you like. We want to end up with x equals, y equals, whatever. Let's get back to this. Probably not the first type of equation you saw. The first type of equation you probably saw back in primary school or maybe even infants. They just didn't use pronumerals. They said things like box plus 2 equals, what goes in the box, or the triangle. Well, when you think about it, that's an equation. They're just using a box or a triangle or whatever as a pronumeral. So x plus 3 equals 6. Not putting it up there is an especially challenging question, more to point out an idea. Some people, when they're shown how to solve equations, have simply said, just do the opposite. I prefer to think of it as moving things. I want to get the x by itself, so I want to move the 3. And the only rule it really is, well, if I move something, I'll change its sign. So when I move the 3 to the other side, it becomes a negative 3. Notice I don't write that down, I'm doing that in my head. But that's how I think about solving equations. Rather than saying, I'm going to do I think of, I'm going to move terms from side to side. And so obviously I get x equals 3. When it comes to a division, okay, here's where I say I've got to do the opposite. I mean, 5 times z, so I'll divide both sides by 5. Again, probably not a step I'd write in, but the reason I put this in is, if it doesn't go in it exactly, I'll always do it as a fraction, because of course that gives you the answer straight away. In this case, 45 divided by 5, of course, equals 9. Parentheses. Well, you've got a choice, really. Do you want to expand out, then move terms, or you could divide both sides by 4? It doesn't really matter. What did I do? I've expanded out, then moved the 20 over, then divided by the 4, whichever way round we go about it. Then we up the ante a bit. Oh, gosh, we've got pronumerals on both sides. But this, again, is where I think the idea of moving terms comes in handy, because it's easy now. Because I can say, I'll just put all the z's on one side and everything else on the other. So as I'll move that over there, it'll become negative 2. The z will go to the left. It'll become a negative z. So I've got 2z is negative 11. Divide both sides by 2. Oh, pronumeral in the bottom of the fraction. Well, to get rid of the fractions, we multiply everything, of course, by the lowest common denominator, in this case 7y, and then we can tidy that one up and get our answer. Well, then we have this special type where you've got fraction equaling fraction. And if you've got that and nothing else, you think of a cross and just multiply along the crosses. And so 3 times the x plus 3, the 5 times the 2x minus 6. And then we can tidy up our new equation. So 7x is 39, 39 on 7. All right, inequalities. An inequality sign will only change in one of 2 cases. If you multiply or divide by a negative number. Okay? Or the way I think of it, if you change the sign, you change the sign. If you change the sign, you change the sign. In other words, because when you multiply or divide by a negative number, essentially you're changing the sign of the number. So if you change the sign of the number, you change the inequality sign as well. So if you change the sign, you change the sign. The other situation, which sometimes we forget, but if you take the reciprocal of both sides, you've got to change the inequality. Let's think of a classic example. It's true to say 2 is greater, actually bad example. 5 is greater than 3. But if I was to turn both sides upside down, it's no longer true. 1/5 is not greater than 1/3. 1/3 is greater than 1/5. So if you were to turn both sides upside down, you would have to change the inequality sign as well. So here we are, 6x is less than 36. Divide both sides by 6. They've done exactly the same as equations. But here's where I want to point out, sometimes we plot our solutions on a number line. Okay, x is less than 6. How do I do it? We just circle the point because it's a boundary and the boundary is not included. It's the same as when you do regions in the plane. If the boundary is not included, you dot it. It's just like the same thing. So I leave this as hollow. I don't colour it in to say, hey, the boundary is not included. And then I just indicate which side. Now, some people are paranoid about this arrow. In fact, I know some teachers are paranoid about this arrow. They'll insist, oh no, it's got to be on the number line itself. Personally, I just put it a little bit above it so I don't lose it on the number line. So if I'm putting a line on top of a line, sometimes I lose the line. So I just put it a little bit above. Some people do ridiculous things like, I'll show you what I have seen. Don't do this, by the way. We go, oh, look, here's 6. Oh, look, all of this here. That's kind of exaggerating it. Just a little bit above so we can see clearly where we're talking about. But the difference with equations and inequations is that you can have more than one side, or sorry, more than two sides. So in this case, where our rule was, whatever you do to one side, you must do to the other. Now it's, whatever I do to one thing, I've got to do to everything. So I'll add the 6, divide by -4. But of course, if I change the sign, I change the sign. Now, I don't know about you, but right now my heart is beating and I'm getting really agitated because that's just horrible. Like, you just don't see inequalities. Oh, no, let's fix it. Oh, that's better. Oh, much better, much better. Okay? Because I always think the solution should look like the number line. I don't see -2 on the right side of 1. So to me, I look at that and it just looks really odd, really strange. But that looks right because -2 is on the left side of 1 on our number line. And to draw that one in, this time they're included, so I would colour them in. And we're in between the two numbers, so I just connect the two dots up. So now for my really fussy, the correct way of writing inequalities. Okay. So we have something like this. That is x is greater than 5. Notice, as I say, it looks like the picture. The arrow's pointing to the same way as the inequality sign and everything. Not, no, 5 is less than x. No. Bad. Because remember, when you're solving an equation or an inequation, they're saying, what is x? I'm answering it. X is greater than 5. If you answer it, 5 is less than x, I don't care about 5. I want to know what x is. All right, so grammatically, oh my gosh, grammar in maths, 5 is less than x is horrible. Okay? And so when we're in between, this time 4 is not included, 6 is included. As I say, it looks like the picture. No, yuck, don't like. Definitely no. All right? Because that is actually wrong. Right? X is greater than 4 or x is less than or equal to 6. Well, that covers every possible number. If you think about it. I want you to give me a number. It either has to be greater than 4 or less than or equal to 6. Every single number satisfies that. Okay? If you did want to, and you don't, but if you did want to, the correct word to put there would be and. Because both must be true. Yuck, that's just plain wrong. All right, how about this situation where we're either side of the points? That is where you would use or. Right? X is less than or equal to 4, or x is going to be greater than or equal to 6. We certainly don't use the word and, because again, that would be impossible. X is less than or equal to 4, and it's greater than or equal to 6. Okay? Can't happen. Right? So or is the correct word to use there. So no, look, yuck. Technically it's, no, I don't even, I am struggling to even say the word here. Technically it's correct. Okay, slip that out. But look, the first line looks like the picture. Look, like that. This one's, no. Horrible. Some people try and write them the same as these ones and do things like this. 4 is greater than or equal to x is greater than or equal to 6. What? No, just wrong. Just wrong. So really, it's one of two things. If you're in between, then you write it in between. If it's either side, then you write it as or. All these things are happening. All right, there we go. 1F.